Assalamualaikum. Good day to all of you. I hope you are in a very good health in your hometown during this MCO period. So we will continue our lecture on maintenance of HVAC system to entire of the semester through online. So in this topic, I will continue on the piping and chiller system. So basically, I would like to focusing on the piping system, but I believe that before we are going to the piping system, it is good if we look back on the chiller system. Before before we are having the MCO PKP, the first phase, I believe that I have bring you guys to the chiller plant room of FTK building. Uh, so maybe some of you guys are not attend the class. So I bring most of your friends to the chiller plant room system. So uh, in the chiller plant room, we have the chill water. So this is the chill water. Why we are using chill water instead of direct expansion? So direct expansion, usually we are calling direct expansion to the for example, split unit system. So it is direct expansion. We are using split unit system and the refrigerant to cool the refrigerant. So why we are using the chill water instead of direct expansion? Because the first one is we want to have the centralized system, and then we want to dehumidify the air in efficient way, and then the location of the chiller plant room also, we it is quite important because we don't want the chiller plant room near to the occupants because of the sound. So we are using centralized system and chill water system instead of direct expansion because of the servicing. Because the servicing for the system is different from the servicing for split unit system. So basically, this is the basic for chiller schematic diagram. So this is, for example, is water cooled chiller. So water cooled chiller is where the component, or what we call, where the equipment that create the chill water. So the chill water will go to the chill water pipe to the air handling unit, or maybe to the fan coil unit. So the chill water system will go to the AHU fan coil unit, and it is pushed by the chill water pump. So in another part of the piping system for the chiller, so we have one more is the open loop system, or what we call the cooling tower system. So this is the condenser water pump that reject the heat to the cooling tower, and it is pumped by the condenser water pump. This is the basic component for the chiller system. So basically we have the cooling coil. So cooling coil, usually it will located in the air handling unit or fan coil unit that is usually above the ceiling, maybe, or in the AHU room we have the AHU, and then the cooling coil is inside the air handling unit, and then we have the cooling tower or the condenser there. Cooling tower, the place where we reject the heat. So usually cooling tower will be located in the rooftop, and then the unit chiller will be located inside the chiller plant room, and we have the pump, either this condenser water pump or the chill water pump. Please be remembered that chill water pump, it will pump the chill water, cool water, and then condenser water pump, the place where the pump to reject the heat to the cooling tower. So basically, how they are doing, how they are making the chill water. So basically, we have four basic components for the air conditioning system, which is the compressor here, and then we have the condenser, which the place where they reject the heat, and then the expansion device to regulate the pressure of the refrigerant. And then one more, we have the evaporator. So evaporator usually we located in the air handling unit or the indoor system. So the evaporator will absorb the heat. So the system will be circulate to the entire time to make sure the occupant receive the correct air temperature and humidity. So this slide will explain to you, this is the schematic how or step on HVAC system selection. So the first one is building drawing. So we have to draw the layout of the entire building that we want to cool down, and then we going to the phase of load estimation, or what we call cooling load estimation. So the cooling load estimation is one of the most important element in system selection of the HVAC system, because if we estimate too big, we are going to select the bigger system, so it will take a lot of cost for the installation, for the selection of the building, selection of the equipment. So if we are estimate it is too low, then the room or the building will not achieve the suitable temperature and humidity that desired to have there. And then the system selection there, then we are going to estimate the chiller size of the building. So please remember, usually chiller will be used for the big system or centralized system. So on previous slide I have told you there is one part of the cooling tower part, and then another part will on the AHU part. So the AHU part there, we have the chill water that supply to the air handling unit. So when the chill water supply to the air handling unit, then the blower will pass through the cooling coil, go to the ducting system variable air volume box, and to the diffuser. So this is the diffuser where it is located in your room or in your space. So this is the closed piping system here. The chill water system going to the cooling coil, and then goes out, going to the pump, chill water pump here, and then going back to the chiller. So in the cooling tower system, we call it open piping system. So open piping system, it goes to the warm water which is from the condenser of the chiller. It goes to the cooling tower where we will reject the heat there, and then going back to the condenser water pump, and then it will coming back to the chiller. So we have one more component here which we call makeup tank. So makeup water tank here is quite important because we want to recover the water that are losing when we are rejecting the heat in the cooling tower. So this is one of quite important figure here, because it will explain all the HVAC system selection on the HVAC component here. The next one, we are looking focusly on the chill water system. So this is the chiller where we are going to supply the chill water. So the chill water will go through the piping system. So the next we will going to the piping system studies. So the piping system for the chiller system, they have various size depending on the capacity on the chill water system what we want to have, and depending on the volume flow rate of the chill water. So the piping system will go to the cooling coil inside the AHU. So this is the example of we have about two coil here. So the cooling coil here, for example, we have this is one air handling unit and this is one more air handling unit. So we will have about two-way valve and then three-way valve depending on the application and of the chill water system. So usually the temperature that are going to the cooling coil is about 45 degrees Fahrenheit, which is about 7 degrees Celsius. So they are coming back to the chiller, which about 13 degrees Celsius, which is about 55 degrees Celsius. So usually the cooling coil, the chill water coming to the cooling coil is about 7 degrees Celsius, and then usually we will get to the room. Usually it's about 16 degrees Celsius because we have the thermostat there in the room. So it's depend on the occupant itself to control the temperature in their room. So they will control by the thermostat there. Then it will tell the sensor here in cooling coil or air handling unit how much or how many chill water we want to supply for the temperature to make sure we achieve. For example, we want about 21 degrees Celsius. They will tell the sensor in air handling unit to make sure we supply about the correct temperature, not too low or not too high temperature. So it will going to the chill water will going back to the chiller system. So next one is basic open loop system. This is for the cooling tower. So basically, the water cool condenser temperature going to the cooling tower, it usually must be higher than the coming back to the chiller. So the temperature for water cool condenser is about 94 to 95 degrees Fahrenheit, which is about 35 degrees Celsius. So after they are going to the cooling tower, the condenser water pump then will be decrease the temperature to about 85 degrees Fahrenheit or about 29 degrees Celsius. So the condenser water pump will suck the water condenser water and then to the chiller. So it will going rotate the condenser water pump to make sure the condenser here reject the heat in the condenser or in the chiller system. So this is the chill water piping system piping. So basically the next one we'll going to the chill water system piping. So they have several material on the piping system depending on the application, but in the piping system for the chill water and condenser water, they are using other material than the piping system for the split unit system. It is obviously different because usually in split unit system you are using only the refrigerant and we are using only copper pipe. So the next study I will show you on the system piping system on the maintenance sites. So this is basically on the basic principle of chiller system, because I believe this is quite important before we are going to the piping and we are going to the ducting. So the duct side is here. Here is duct side or what we call air side. So see you next time on the piping and ducting side. Thank you very much.